Stargazing Week. It is a celebration of Minnesota's dark sky parks, Voyageurs National Park, and Boundary Waters Canoe Area Wilderness. Many partners have come together to host a week of free activities across Minnesota, both in person and virtually. Boreal Stargazing Week programs are brought to you by Voyageurs Conservancy, Friends of the Boundary Waters Wilderness, Starry Skies North, Voyageurs National Park, Superior National Forest, Expeditions and Education, the Bell Museum, Wood Lake Nature Center, and NASA's Goddard Space Flight. So we got lots of activities. Come to any one of our events. So as an introduction, my name is Jesse. I'm the education specialist at Voyageurs Conservancy, which is the official nonprofit partner for Voyageurs National Park. For those of you who have never been to Voyageurs National Park or you don't know where it is located in northern Minnesota. Here we have a map of the United States. We can see the outline of Minnesota, and we can see this red pin, which shows you where Voyageurs National Park is. So it's really as far north as it gets. We're known for many things, but mostly our chance to get out on the water. You can get out on a canoe or a kayak, a pontoon boat, or even a tour boat. But here at the Voyageurs Conservancy, our mission, our kind of main thing that we want to accomplish is to connect people to Voyageurs National Park, enhance the visitor experience, and protect the park for present and future generations. Now, we do that in a number of different ways, but as for myself, the person who is deeply involved in education, the way that this looks is I deliver hands-on activities for both students and for the public that help them gain that appreciation for Voyageurs National Park. And additionally, what that means is we teach about the importance of the night sky and its preservation. Voyageurs National Park is a place where you can see literally, not exaggerating, literally thousands of stars on a good night. And night skies are kind of becoming a rarity in the country and also throughout the globe. So it is something that we really cherish. We really love our dark skies. And a way to really express that is I do a lot of the education programs about night skies. We do constellation stories. We look at really cool things through the telescope. We design big festivals such as this one to show our appreciation of the night sky. And of course, I do virtual programs like this one. So I hope my presentation inspires you to feel connected with the night sky and understand why dark sky places like Voyageurs National Park are just so important. And so that brings us to our presentation. Today's presentation is called Winter Night Skies and the Aurora Borealis. So it's kind of a two-part program. For the first part, we'll be talking about winter night skies. And for the second portion, we will be talking all about the Aurora Borealis. So for the first part, winter night skies, this is kind of where we will be going throughout this presentation. We're going to talk about why you should stargaze in the wintertime. We're going to meet a few of the winter constellations, and then I'm going to teach you how you can experience the winter night sky all on your own. So with that out of the way, let's dive right into it. All right, so why should you go stargazing in the wintertime? It might seem like you wouldn't want to go, particularly if you don't like the cold weather, but I'll tell you right now, there are some really good benefits to stargaze in the winter over the summer. One of those is that the stars that you see will be much more clear. And the reason for that is that in the summertime, there's lots of moisture in the air. That is, the air is holding water. And what happens is when the starlight comes through, it makes it all blurry. It's kind of like looking through a blurry glass. And so it kind of ruins the quality of the stars. But in the winter, the cold air holds less moisture, and therefore the stars that you do see are a lot more crisp and clear. Another benefit to stargazing in the wintertime is that it gets dark way earlier. So I know a lot of people want to go stargazing, but they don't want to stay up super late. especially here in northern Minnesota in the summer, it'll be like 10 p.m. and it's not even dark yet. So it's a big commitment if you're an early bird. But in the wintertime, it's already dark by like 6 or 7 p.m. So if you're an early bird, stargazing in the winter is the way to go. And the last reason you should stargaze in the winter, it might sound silly, but it's totally true. There are no mosquitoes. They all go home for the winter. And that's a good thing, especially here in northern Minnesota. It is really bad. I've been out there in the dark and I put on a flashlight and there's literally thousands of mosquitoes just swarming my head. So if you don't like mosquitoes, you got to stargaze in the winter. And I think it is really important. I think one of the most beautiful things about stargazing in the winter is being underneath the stars, being immersed with the whole experience. And it's really hard to enter that mental state when you have mosquitoes buzzing around you. So wintertime, I've seen some of the best stars in the winter. All right, so now we're gonna meet some of the winter constellations. Were you aware that the stars change throughout the season? That means that the stars that you see in the summertime are different than the ones that you see in the winter. And we can see a lot of crazy names over here, the shapes of the constellations. And while I do love them all, we're gonna narrow our focus to just 3 of them. Canis Major, the Big Dog, Orion, who is the Hunter, and Taurus, who is the Bull. So you can see all of these winter constellations, they are right next to each other. So as you start to learn one, you can start to kind of build on your knowledge, and they're all close to each other. So you're not having to look in all these different places in the sky. You just look in one direction. And this part is called experiencing the winter night sky, because I don't want you to just learn about it. I want you to take what you learn and then go out and experience it all on your own, because I think it's just one of the best activities that you can do. So we're gonna revisit these constellations that I just mentioned, and we are going to see what interesting things are within them. All right, let's start with Canis Major, the Big Dog. Right away, looking at Canis Major, the Big Dog, you'll see this really, really, really bright star. This star is actually the brightest star in the entire night sky. So it's really easy to find for that reason. And for this part, I do want to throw a little trivia question for you. So what you can do is go into the Q&A section and you can go ahead and answer this question. The question is, what is the name of this really bright star in Canis Major? And I'll give you 10 to 20 seconds to think about that and to write your answer. And if you're a Harry Potter fan, there is a hint here, and that hint is, who is Harry Potter's godfather? All right. All right, we see some answers flowing through. All right, very good. And if you're 2 decades late to the party, don't look at the answer or cover your ears, because I'm about to reveal a spoiler. The answer to this, I saw a lot of correct answers. It is Sirius. Very good. Virtual high fives for everyone. Yes, Sirius Black, and that is the name of the star, is Sirius. Another way to remember it, what does Sirius Black turn into? He turns into the dog. I forget the technical name for it, but it's a dog. And what star is it in? It's in Canis Major, the Big Dog. So that's just a few little connections you can put in your head to really remember that. When you go out and try to find Sirius on your own, I challenge you to do this now, and you can just answer in your head and lock in an answer. I want you to look at the starry night sky, and I want you to choose in your head which one you think Sirius is. And remember, it's the brightest star out there. So just look for the one that looks the most bright. You can have like 2 answers if you're not sure, but we're going to reveal the answer in 3, 2, 1. Sirius is right there. Again, it is the brightest star in the night sky. So if you're new to this and it's a little bit intimidating, Sirius is a great place to start because It's so bright, it's the brightest, and it's kind of right in your face. Sirius, again, part of Canis Major. All right, the next one we're moving on to is Orion the Hunter, maybe one of the most famous constellations out there. And I got another trivia question for you, so go ahead and go into the Q&A section. My question to you this time is, what is the name, this pattern of stars that I circled in red? Give you about 10 seconds, maybe 15 to think about it. All right, you guys are good at this. Very good, I'll give you a few more seconds. Looks like everyone's getting it though. The belt, yes, this is none other than Orion's belt. And Orion's belt is great. It's those three distinct stars in a row. And you might be asking yourself, how do you know if it's Orion's belt or not? If you're imaginative enough, you can make 3 stars in any part of the sky if you wanted to. But what we're going to do is learn other parts to Orion that you can use to help test your answer. So we're gonna lock in your answer to what you think Orion is, and we're going to use things around it to help solidify your answer. So what I want you to focus on is, if you look above Orion's belt, you'll see a reddish star, like an orangish reddish star. And that is none other than Betelgeuse, which is an interesting name. Just don't say it 3 times in a row. Betelgeuse is actually an Arabic word that I believe translates to armpit of the giant. And so if you look at Orion, you look at the placement of it, it is in his armpit. So that's another way to remember that. So again, if you're out stargazing and you see 3 stars, well, I see 3 over here. I think that's Orion's belt. I'm gonna mentally lock that answer in. What do I do to test that? I look nearby. Do I see an orange star? Yes, I do, right over here. And that's the cool thing. When you look out at the star, it really is red. It's like a reddish orange color. You really do see it with your naked eye. And then you bring a telescope up to it, and you get this piercing red glow that just shines into your eye. It is so cool. One of the things that you may not recognize just by looking at it like this is the true tremendous size of Betelgeuse. Okay, so what we're going to do now to really appreciate the size of Betelgeuse is, first we're going to look at our mighty sun and compare it in size to our planet. So this is kind of a starting point. We have the sun over here. This is a scale model, meaning this is how the objects would look next to each other. We've got the mighty, powerful sun over here. And where's Earth? I have a hard time even finding it. It looks like this tiny little pebble over here, which is pretty crazy. Think of the grandest thing you know of on Earth. Think of Mount Everest or the depths of the Pacific Ocean. Well, guess what? It's on this tiny little pebble that we call Earth. Okay, so that's the first thing I want you to think of. Now we're going to compare the mighty, powerful sun to Betelgeuse. How does it compare to the size of this star? Well, now we're going to zoom out and we're going to see the size comparison. Now we have Betelgeuse over here, this giant, massive red star. And where's the sun? Where is it? Where is it? Oh, there it is. This tiny little object over here. So now the sun looks like a pebble compared to Betelgeuse. And so my point here is that Betelgeuse is just mind-bogglingly huge. It is super giant. And in fact, these types of stars have a very specific type of name that we call them. First of all, these stars are red. We could describe them as supergiant. And so if you were to put a creative name together, you could call it a red supergiant, which is very straightforward, a little bit on the nose, but I like these definitions that are simple. So again, these types of stars are called red supergiants. And guess what? They're scattered all throughout space. That's just one example of a red supergiant. Another really cool thing is in the opposite direction of where we saw Betelgeuse is down here. In fact, if you look in this section of sky with your naked eye, you will see a section of sky that is kind of fuzzy and white. But if you bring a telescope up to it, you will be met be pleasantly be met with the Orion Nebula. It's one of my favorite things to look at. When you look at it, it won't look like this. This is a NASA image with special imaging techniques, but it is still a really beautiful thing to look at. You'll see it as a white, kind of smudged material. And these areas are actually what we call star nurseries. It's where stars are literally born. Baby stars are being born in these nebulae. And what happens is these areas are filled with clouds of dust and gas, which eventually kind of collapse in on themselves and create the beginning stages of a star. And after enough stuff is added to it, enough heat and enough pressure is added, it is kind of born into existence. The stars pop out, and we can now call it a baby star. So again, the Orion Nebula is a place where baby stars are being born. And moving on to the last of our winter constellations, we have Taurus, the bull. The thing that I like about this constellation is you can see these nice long horns. You can also see this red star named Aldebaran, another beautiful red star. But what I want to direct our attention to is this over here, this little cluster of stars contained within it. And so this is my final little trivia question for you. Go into the Q&A and type your answer. You've got about 15 seconds to do so. My question is, what is the name of this cluster of stars? And it does go by many names. I will be very shocked if anyone even knows any of them, because it is quite tricky. All right, we're getting some guesses. Okay, yeah, I'm seeing some differing answers. I'm glad you're all getting into it. All right, and the answer is, I saw the correct answer there, the Pleiades. Very good. So it goes by a few names, the Pleiades, the Seven Sisters, because you can count 7 stars there with your naked eye if you've got really good eyesight, and also Subaru. That brings me to a fun little fact. This is maybe more for the adults in the crowd, but if you look at this cluster of stars, it looks like this. And if you look at the logo of a Subaru car, or if you own a Subaru, you might know that the logo is a cluster of stars. And guess what? That is no coincidence. That is what the Japanese car company named their logo, or made their logo after. So now you won't be able to look at your Subaru without thinking of that fact. But you should do yourself a favor and look at the real thing. Get yourself a pair of binoculars, and it'll really come to life. You'll see these piercing white and blue stars surrounded by these wispy tendrils of nebulosity. It is so cool. It's probably, I'd say, like in my top 5 favorite things to look at with a pair of binoculars. So these are the winter constellations. This last one I wanted to throw in as a bonus, in case you become inspired by this and you want to go out and learn these on your own. There's a really cool shape that you can make that connects all of the winter constellations together into one. So what we're going to do is we're going to start at Canis Major. We're going to go through a star in Orion. We're going to move up to a star in Taurus. And then we're going to connect through other winter constellations that we haven't reviewed. But what you're going to see is this 6-sided shape. A 6-sided shape is called a hexagon. And since all these constellations are seen in the wintertime, we love these simple names. We're going to call this the winter hexagon. So, and this is kind of, this is like the boss battle. You can think of it. You do this once you become more and more comfortable with the constellations. You can use this to really test your skills. And my last note on winter constellations and experience in the winter night sky, if you are interested in this, my recommendation is to really just give yourself some time to soak it all in. Because I know if you just start this or you didn't grow up seeing stars, the thought of it can be kind of intimidating or overwhelming. But again, my advice is to just take it really slow. If you could just go out every night and confidently identify Sirius, and it takes you a month, or it takes you however long it needs to take you, I think that's an accomplishment. You should just kind of take these baby steps, and eventually it'll become automatic. You can use the stars that you do know as stepping stones to find new ones, and you kind of unlock new parts of the night sky. I think it's such a rewarding and just humbling experience. It's something that I really cherish and I think is just a great hobby to get into. So if you have any questions about that, please ask me either during the Q&A or shoot me an email. I'd love to help out in any way that I can. So viewing the winter night sky, you might be blessed with seeing this thing in this picture. I love this picture. This is known as the Aurora Borealis. In the wintertime, such a good time to view them. So that kind of segues us into the second portion of this presentation, which is called the Aurora Borealis. For this part of the presentation, we're going to cover everything that you see on the screen. We're going to learn what it is. We're going to learn how they form. We're going to learn about the colors. We're going to learn why this is a good year to see them. And we're going to see how to increase your chances so that you can see them all on your own. So the first question is, what is the Aurora Borealis? If you kind of want a technical definition, I put it at the bottom of the screen, but a very simple way you can think of it is it's just shining colorful lights in the night sky. Now, all the pictures I'm about to show you were taken at Voyageurs National Park, because again, you can see them up here. And what I want you to focus on is the true diversity of northern lights. That is all the different variety of forms and textures that you see, because you can see from these pictures, they're not all identical. Sometimes they're kind of wispy and light. Other times they're really vibrant and in your face. Sometimes they're just solid and they're not moving at all. And then other times they're just filled with brilliant colors. You can see a variety of different colors. So again, the Aurora Borealis, it's colorful lights in the night sky that come in a variety of different forms. But the big question that I get this all the time. The big question I get is, how do they form? How do you go from looking at a starry night view like the one you see in this picture to one that is just filled with lights dancing across the sky? For that, we have to move on to this section, which is, how do auroras form? Auroras form by considering three things. There are the interactions of three things coming together, and that is how auroras form. So by the end of this portion of the talk, if anyone asks you how do they form, you just got to remember three things. And I'm confident that all of you can do that. These three things are, you need an atmosphere filled with molecules. 2, you need a magnetic field that surrounds your planet. And 3, you need powerful bursts of energy coming from the sun. Those are the three things you need. Let's walk through each one of those. The first one is you need an atmosphere filled with molecules. Earth's atmosphere is a blanket of air that surrounds the planet, starting from the surface, and it goes all the way up into the space where it kind of just chisels out. It's so easy to think of the atmosphere as nothingness or emptiness. You know, when I move my hand like this, there's nothing blocking it, so we might think that there's nothing there, but that's not true. Our atmosphere is filled with tiny little things that we call molecules. Our atmosphere is mostly made up of molecules in the form of nitrogen, a big chunk of oxygen, and then some other stuff. So it's mostly nitrogen and oxygen. So when I move my hand like this, in reality, I'm actually pushing through tons and tons and tons of molecules of nitrogen and oxygen. Okay, so that's the first step. Just remember that for now. Earth has an atmosphere filled with molecules. The second thing you need to know is that Earth has a magnetic field. It's a protective force field that surrounds our planet. Now, the reason that we have a magnetic field is pretty cool. You actually have to go deep down into the center of our planet, go through all the layers until you get to the center where it says outer core and inner core. Our outer core and inner core are made up of liquid and solid metal. Isn't that crazy? We have liquid and solid metal deep down the center of our planet. Now, due to the intense heat and the intense pressure at this depth, and due to the material, the liquid and solid metal, all interacting together, it actually creates a really amazing effect, which is it actually creates magnetism. These magnetic bands kind of shoot out of the planet. They shoot out of the North and the South Pole, and they connect, and they give us this nice protective force field surrounding our planet. So again, Earth has a magnetic field. That's the second thing you need to remember. And this is all going to beautifully come together in just a moment. Just remember this for now. Earth has a magnetic field. The third thing you need to remember, learn how auroras form. We need to direct our attention to the good old sun. I love the sun. I associate it with jumping in lakes in the summertime, just fully enjoying the warmth. It allows the plants to grow. It allows every single person you love on planet Earth to continue to live. But make no mistake, the sun is a really deadly, powerful, chaotic place as well. Every second that the sun burns, it releases huge amounts of energy in these big, giant explosions. Again, every single second, these explosions are going off, and it is releasing a tremendous amount of energy. Sometimes it releases so much energy that actual material from the sun blasts out into space in this really fancy word that we call a coronal mass ejection. Coronal mass ejections are actually stuff being blasted out from the sun. And the sun will blast these coronal mass ejections in any direction. Sometimes, as a consequence, though, little poor old Earth over here happens to be in the line of sight of this giant, deadly coronal mass ejection. This is crazy. We've already looked at the size comparison of the Earth versus the sun. We are nothing in comparison in size. Is there anything out there that can protect us from the sun's coronal mass ejection? What do you guys think? Is there anything out there that can protect us? I'm going to reveal the answer. We do have something in 3, 2, 1. We've got a magnetic field. Woo-hoo! So Earth's magnetic field is really important. So when the sun blasts coronal mass ejections at the Earth says, I'm not worried about it. It uses our magnetic field to protect us. It deflects that material outward, and then it kind of gets vacuumed back into the Earth. But now it's weakened and it's not deadly to us anymore. It gets weakened and it gets vacuumed into the North Pole and into the South Pole. And when that weakened material from the coronal mass ejection enters towards the Earth, it goes through our atmosphere. And when it goes through the atmosphere, it doesn't go through nothing. It bumps into molecules in our atmosphere. It bumps into the nitrogen. It bumps into the oxygen. It excites the material. And as a result, it causes it to flash brilliant colors. How cool. We saw it all come together. So I know that was a lot of information, but if you remember those three things, the sun blasts material at the Earth, Earth deflects it with its magnetic field, and it bumps into material in our atmosphere. That pretty much sums up the whole process. And you might be asking yourself, at least I asked myself when I first learned this, what if another planet has those three things happening? Can they get auroras as well? And the answer to that is yes. Look at that. We've got Saturn over here and Jupiter, as if they weren't cool enough to begin with. Now we know that they have auroras on them as well. Now, another common question that I get is, how do the colors form? Why do we see a variety of reds and greens and colors like that? And I'll tell you right now, it has to do with the molecules in our atmosphere and the elevation in which they are residing. And so if you remember from a moment ago, we have mostly nitrogen and oxygen in our atmosphere. Now we're going to see how elevation plays a role in this. we have an elevation kind of column over here. We can see this would be the surface, and moving our way up, I labeled them both kilometers and miles. We can see that clouds usually taper out over here. Maybe they go a little bit higher. But as we work our way upwards, we'll start to see the aurora. Now you'll notice at this elevation, we see this kind of purplish color. Purple is formed when the material from the coronal mass ejection bumps into nitrogen at this elevation above the ground. When it bumps into it, nitrogen at this elevation, it begins to flash blue and purple. But if we work our way upwards, at this elevation, we see oxygen. When material from the coronal mass ejection bumps into oxygen at this specific elevation, it'll begin to flash green, perhaps the most common color of the auroras. And if you work your way up to the top, kind of the topmost part of the aurora, you'll see red. Red is when stuff from the coronal mass ejection bumps into oxygen and excites it there. So we can see oxygen can give you two different colors depending on the elevation in which the stuff is being bumped into. So it's kind of cool when you're looking at the Aurora Borealis and you see all these different colors, you're really seeing a three-dimensional kind of art display of different material interacting with stuff from the sun. Now, you may have seen in news headlines that 2024 is a really good year to see the auroras, and this is true. The reason for this is that we have something called a solar cycle or sun cycle. It lasts about 11 years before repeating itself. So in this chart, we can see the years on the bottom, and we see these crazy kind of lines. During this 11-year period, you see that the sun is very inactive, and then towards the middle of the cycle, it becomes very, very active, and then it goes back to being inactive, and then it goes back to being very active. So that's kind of the trend as we see during the 11-year cycle, it's very quiet in the beginning, and then it's very active in the middle. And what do I mean when I say active? I mean those blasts coming out from the sun, those coronal mass ejection. That means that the sun is very, very active. And so we can see from this picture that the graph stops at 2020. That would be the beginning of a new cycle. But if it kept going, you would see the peak in activity start to go up in the middle of it. And guess what? 2024 is the middle of the cycle. So again, the middle of the cycle is when you get the most activity and therefore the most auroras. We're currently in the middle of that, which means you've got a really good chance of seeing them this year. And the last thing I want to mention about the auroras is a little note on how to increase your chances of seeing them. If you want to see the Aurora Borealis, I made this quick little checklist that you can check off to increase your chances. So it doesn't guarantee it, but it gives you the best chance you can get. Here they are. I've wrote them out here. And we're going to review each one of these in a little more detail right now. So the first one says there's a high rating on a KP index. What does that mean? All it means is you have to download an app or check a website. If you just type in Aurora into your Google Play Store or whatever format that you have, you'll see hundreds of different apps which essentially do the same thing. And it's essentially a weather forecast, but for the Aurora Borealis. So in this example, we can see the dates laid out here. We can see the ratings as well. And so these dates over here, these are a low rating, so you probably don't want to give it a shot then. These dates over here are a medium chance, while this one in red is a high chance. So those are the ones that you want to go out on if you want to be strategic. In fact, some of these apps will even give you an alert on your phone when they're actively going out. So those can be good to set up. The second one on the checklist I mentioned is to go at a high latitudes. If you don't recall, here's the globe, and lines of latitude are the horizontal lines. We can see that the equator is labeled as 0, and they go in increments of 30 in both the north direction and the south direction. So what you want to do if you want to increase your chance of seeing them is you want to get as far away from the equator as possible, whether that's in the north direction or the south direction, both are okay. So for example, Voyageurs is in the 40 range. I would classify that as a high latitude. So you want to go far away from the equator. If you're by the equator, you're not likely to see the Aurora Borealis. And the third one I mentioned on this checklist is you don't want any obstructions in the night sky. And what do I mean by that? I mean, we don't want clouds in the way, and we don't want light pollution, just the invasion of night skies by artificial light. Because sometimes what could happen, it's a shame, but this happens. Sometimes the northern lights are dancing above your head, they are vibrant, they are active, but you look up and there's clouds in the way. Or you're in a big city and there's too much light pollution, which blocks it out. So if you really want to increase your chances, we say, get out of here, clouds, get out of here, light pollution, check the weather and go to a place with minimal light pollution. So again, if you do all three of those things, it doesn't guarantee it, but it does give you a better chance of seeing them. So you want to be strategic with it. It really is a life-changing experience to see this. So I hope you follow this after this presentation. And what I want to end on is this thing known as night sky preservation. So here at Voyageurs National Park, we take this really seriously because what we're seeing now is this issue known as light pollution. Light pollution is the invasion of night skies by artificial light. And we can see from the satellite image that light pollution is all over the country. Even without the borders of the states put on, we can see the locations of big cities just based on the light that they produce and they shine out into the sky. Now, if you haven't heard of light pollution before, you might be easy to think that it's not an issue. You spend your whole day around light and you don't feel bad at all. But numerous scientific studies have been showing that light pollution has several negative effects. It affects animals and the larger ecosystem, the interactions between predator and prey, and specifically nocturnal animals. It affects humans, our mental and our physical health. It affects businesses, it affects our wallet because it's just wasteful. We're shining all that light into the sky rather than containing it where it is needed. It erases our cultural ties to the night sky and our history. And it also just erases the environment to look up and to be curious and have those kind of deep moments underneath the stars. And so I'm not saying that light is a bad thing all on its own. It's just when we have too much of it, we can see that it has several adverse or negative effects. And we can see that it's not only in the United States. If we zoom out, we can see that light pollution has negative effects all across the globe. But it's not all bad news. There are some really great organizations out there working to combat this. Probably the most famous one is the International Dark Sky Association, or the IDA. What the IDA does is they work with different areas to help them become more dark sky friendly. What that means is they work with them on lighting plans so that they're really aware of the lights that they're putting out there. And then once they have done this, they've taken all the steps necessary, they are awarded with a certificate, a dark sky park certificate. And guess what? Voyageurs National Park got theirs a few years ago. Same with the Boundary Waters, which is right nearby. And so these are places where you can see the stars. Again, this is becoming a really rare thing. 8 out of 10 people that live in the United States cannot see the Milky Way from their own backyard. And so people are coming to places like Voyageurs and to Boundary Waters to have these moments. I think there is something within us as humans that really loves just being underneath the stars and just connected with it all. But one thing I want to say is that once you get your certificate, you don't just get it and then you can go put a Walmart up and have lights shining everywhere. No, you have to continue to prove that you're an advocate of dark skies and a fighter of light pollution. And we do that in a few different ways. One way that we do this is we use this little tiny device called a sky quality meter. It fits in the palm of your hand, and all you do is you point it up to the sky and you press the button, and it records an actual quantitative measurement of darkness. Now, as far as the actual number goes, don't worry about that. All you need to know is that if you took this device in a place like New York City and you pointed it up, you'd get one end of the spectrum. If you took the same device and pointed it up in Voyageurs National Park, you get the opposite end of that spectrum. So again, this shows you an actual quantitative measurement of darkness, and we have to submit these numbers to the International Darkest Sky Association every single month to show that we're continuing to remain dark. And the other thing that we do is an educational component. So what I do as the person who really loves dark skies here is I present a number of different programs and I help out with festivals which celebrate our dark skies. So we go out there, we have a really cool laser pointer, I'll point out the constellations. We have a giant telescope, we see amazing things through it. We talk about the adverse or negative impacts of light pollution and what you can do to combat it. And if you're lucky enough, like this night that we were out, you could see the northern lights. That was such a cool night. And so the International Dark Sky Association truly is international. I know we may have some people on this call who are from another country. So I did want to point this out. They work with areas across the globe, and it is really gaining momentum. So if you are interested, please shoot me a question about it. I'd be happy to point you towards the resources so that you can get involved as well. Wow, that was a lot of information. I like to kind of just reel it all back in and just have a conclusion, talk about all these different cool things we discussed during this presentation. We started off with winter night skies. We started off with talking about the numerous benefits of why stargazing in the winter can actually be beneficial over viewing in the summer. We talked about 3 winter constellations, Canis Major, the Big Dog, Orion the Hunter, and Taurus the Bull. And then we really got to experience each of those. Because again, I want you to walk away with these and try it on your own. We learned that Canis Major has the brightest star in the night sky, which is Sirius. Then we learned about finding Orion's belt and how if you look up in the corner, you can find Betelgeuse, the red supergiant. And if you look in the other direction, you can see the Orion Nebula, place where baby stars are being born. Then we learned about in Taurus the Bull, how if you look off to the side, you'll be met with this brilliant, bright cluster of stars known as Pleiades, Subaru, and the Seven Sisters. And then we ended this portion of the talk talking about how you can weave all these winter constellations together in the winter hexagon once you become a little more comfortable with stargazing. For the second portion of the talk, we reviewed the Aurora Borealis, and we got a well-rounded understanding. We learned what it is, defining it as colorful lights that come in a variety of different shapes and sizes. We learned how they form by learning that the auroras form by the interaction of coronal mass ejections being deflected by Earth's magnetic field and then interacting with the molecules in our atmosphere. We learned that the colors are determined by the elevation and the molecules being bumped into to create a variety of different colors. We learned that 2024 is an excellent year to view them based on the fact that we are in the period of time where the sun is most active, which will give us the most brilliant auroras. And then for this last portion of this talk, we mentioned how to increase your chances so that you can not only know about them, but you can go out and see this on your own. And this is done by downloading an app, going very far north or very far south, and going somewhere without anything in the sky that would block you. And then we finally ended the talk on night sky preservation. We learned that light pollution is the invasion of night skies by artificial light, and it has several negative areas in which it affects. But there are organizations such as the International Dark Sky Association that works with areas such as Voyageurs National Park to really preserve the night sky and to show why it's such a valuable thing to preserve. I know that was a lot of information. I really appreciate you sticking through, and I appreciate you coming to the presentation to begin with, because it shows a curiosity or an interest in the subject. Thank you again so much. And I will now stick around for the remainder of this time for questions and answers. Thank you so much.
Hi, Jesse. Thanks so much. Let's give some love for Jesse in the chat. If you can put some emojis in there. Thank you. We do have a couple of questions, Jesse.
Yeah, let's hear it.
The first one, how long have you been doing this?
Yeah, that's a great question. I started in 2017. I worked as a park ranger before, and I remember when I first got into it, I've always had an interest in the night sky, but I grew up in New York City, so I had an interest for it, but I never had an outlet or the environment to experience it. And so I entered this national park knowing that they worked with telescopes, but I was just so scared of even touching one of those. I could barely even find the Big Dipper when I first got there. But when I got there, I just fell in love with it. I wanted to learn all about the telescopes. I'd go out on my free time and I would start trying to test my knowledge on which constellations I could find. And then slowly through that, from 2017 until now, I pretty consistently have been going out, whether it's from working jobs or just going out to my free time, to really try to learn about the night sky, to be intimately connected with it. So started in 2017, been more or less doing it continuously until now. Great question.
All right, before I go to the next one, if you do have questions, instead of raising your hand, please pop those in the Q&A at that. You're going to see that at the bottom bar of your screen, and that's how we'll be able to get those to Jesse. Jesse, your favorite constellation?
Oh, man, that's a tough one. I'm going to give a cop-out answer and give a few because there's just so many cool ones. In summertime, I really love Scorpius. Scorpius, if you don't know, is a giant scorpion. And what I love about Scorpius is, one, the size of it. It just takes over a huge portion of the sky. And the other thing is, when you look at it, it really does have a long kind of swooping tail, and it looks like there's a stinger on the end. If you ever looked at pictures of constellations, they usually don't look like the thing that they advertise to be, but Scorpius is an exception. Scorpius really does truly look like a giant scorpion. It's also got a beautiful red star in the center of it named Antares. So lots of cool things about Scorpius. In the wintertime, though, I probably have to go with Orion, just because it's one of the first ones I ever learned confidently, where I could go out and get it every single time. And it's got all those cool things we talked about. And then I'll give you one more. There's one named Delphinius, which is a tiny little dolphin that you can see in the summertime. It's a little faint, but it looks like, you know how little kids draw fishes or fish? It kind of reminds me of that, like a little goldfish or something. So Delphinius is a faint one, but it's probably one of my all-time favorites.
All right. Gabby wants to know, how do you know all of this?
I know this because I am genuinely curious about it. So I am always looking stuff up. I try to go out as much as I can. Anytime there's a clear night, I'll layer up and I'll do whatever it takes to go out there and to experience it. And when I first started, this is actually really important. I went out with people who knew how to do this and were patient in teaching it, because I've had some experiences where you go out with someone who's very experienced, but they go through it very quickly and they say, here's the constellation, and they shape it in 2 seconds, and then you never retain it. So I was lucky enough to have some really great mentors. I was lucky enough to have jobs different jobs where they gave me the time to research it and to dive into it. And so I took really small baby steps um, until I became comfortable. Another resource I'll throw out there, one that really got me to go out there on my own, is a book named The Stars, the big blue book, and it was written by H.A. Rey. And if you don't know who H.A. Rey is, he wrote the book Curious George about the little monkey. They go on adventures and stuff. Anyway, he was an amateur astronomer, and he wrote a really fantastic book that kind of walks you through it. I love that book. I still use it today. Uh, and then the third thing I do is I bought a pair of binoculars. They're not that expensive. And I went out and I tried to seek things on my own. Because I think it's one thing to read about this stuff on a web page, but it's another thing to go out there and to test your own skills. I think that's where you really feel connected, and that's where you really have those special moments. So I know there's a big answer, but those three parts were find a mentor who is patient and willing to walk through it with you, use a resource like The Stars by H.A. Rey, and go out there and try to experience it on your own. Don't just read it on a website. Go out and test yourself.
All right, Claire is referencing part of your light pollution segment and asks, would it fix the problem if we turned off all the lights?
Yes, it would. And it's kind of a crazy thing because the interesting thing is if, unlike other forms of pollution, like pollution of the air and pollution of the water and the soil, which are really complicated and take decades of dedicated work to fix, they kind of linger there. Light pollution, if all of the lights on planet Earth somehow just went out right now, the result would be instantaneous. You would be able to suddenly see the Milky Way, you'd see stars, even if you were in New York City. In fact, there's a funny story, I think it was somewhere in Southern California, maybe LA, where they had a blackout. And suddenly the Milky Way was beaming across the sky and people were calling 911. They're like, there's like a UFO, there's a crazy thing in the sky. And they're like, no, that's just the Milky Way. You've just never seen it before. So to answer your question, yes, it would fix the problem. I don't think that's what the answer is because it's unrealistic to say, everybody turn your lights off right now, because there's a lot of positive benefits of having lights. But what we want to do, what we want to accomplish is to have our big metropolises running more or less the way that they do, but use our lights more efficiently. Use the right type of light bulb, point them down to the ground. Yeah, it's about using light responsibly, not about eliminating light altogether.
All right, Silas asks, how do solar flares happen?
Oh, that's a complicated one. All right. So what's happening in the center of the sun, you can look up something called nuclear fusion. And nuclear fusion is when you take two hydrogen atoms, which the sun is mostly made up of, and you squeeze them like unbearably so, to the fact where it actually fuses them together and it releases energy, and it also creates helium. It's a really complicated process. If I'm being honest, I don't even fully understand it. I've done hours of reading on it. It's super fascinating. So if you're interested, look up nuclear fusion. But in any case, that is kind of the energy source. That's where the energy starts to swell up and kind of work its way out into the sun. And so it is all connected. That's probably my best kind of short answer for it. But if you look up nuclear fusion and solar flares, it'll get you on the path to a more kind of detailed answer. It's a really good question.
All right, we have a class from New Jersey, and they are grateful for this program because they have limited night sky exposure. They were wondering how much hydrogen is there still in the sun?
Ooh, I love that question because it brings up a really good point. So that thing that I just said is called nuclear fusion. It's kind of like the fuel needed to cause the star to continue to burn brightly. And it only has a limited supply. And so the question was, how much does it have left before it completely runs out of the tank? We got an empty tank now. I believe we're about halfway through the tank. So it'll still last for a few more billions of years, but a really interesting thing happens once it starts to run low on its fuel supply. Because of really complicated processes, um, basically what happens is the hydrogen, the nuclear fusion causes the star to swell outward. And then once it runs out, the star actually begins to shrink because gravity collapses in on it. And then it heats up a new portion of the sun that wasn't being utilized before. And a counterintuitive thing happens. It swells bigger. It turns into what we call a red giant. We saw red supergiants in this presentation. That's on a whole other level. But with our sun, it's going to swell into a red giant. And then eventually it'll completely run out of its fuel. It'll have no more hydrogen. And then it's got nothing more to cause it to burn brightly. And then it kind of just peacefully fades away into what you can call like a ghost of a star. That's not the real name for it, but that's how I remember it. I'll show you an example of one. Can you still see my screen okay? So this is a beautiful example, probably the most prominent example. This is what happens when an average sized star like our sun runs out of its hydrogen supply. It expands into the red giant, and then once it's completely done, it just kind of whiffs peacefully away into the night, leaving behind this shape. And if you look really carefully, in the center of it, you'll see a white dot. That is the core of the star. We call it a white dwarf. But this outer layer kind of resembles the shape of that star before it went away to pass away. Great question.
Okay. How does a star burn if there is not oxygen in space?
Yeah, so that's a really good question. So the way that we get fire on planet Earth, you do need oxygen, but the sun, it's not fire that's being lit. It's its own process. That's where the nuclear fusion comes in. So nuclear fusion is an entirely different realm than what you need in order to create fire on Earth. So the flame you see on planet Earth is entirely separate from nuclear fusion going on in a star.
All right, we're gonna do one more and then go to Northern Lights. So Jesse,
Yeah.
how many times have you seen the Northern Lights?
I've seen them, I think, about 7 or 8 times now. And I've seen them, the first time I saw them was really cool. I was out with a bunch of visitors just doing one of my programs, and I'd never seen them before, so I didn't know what to really expect. But I knew it was a high rating, so I brought my camera out, and it started off as like kind of a wispy white, just kind of a vague shape. And I was like, I don't know if that's it. So I brought out my camera, I messed with my settings, I did a long exposure, and then sure enough, it started to come back green. And then after that, after like 30 minutes or so, the green actually became present in our eyes. And so it slowly came to life. I was with probably 10 other people. It was their first time as well. So it was really just a beautiful moment. Just a bunch of our first time, just hoping for it to come to life. And then sure enough, it did. And actually, in one of these slides, let's see if I can pull it up again. In one of these slides, is probably one of my favorite times to see it. And this one over here, this time, it's probably the most active I've ever seen it, and the most vibrant green. And it started off as just like a thick, kind of unmoving piece of green. And there was a whole crowd of us. People had chairs out, we were lined up on the docks. And then after like 30 or 40 minutes, it just became electric. It became filled with motion and color. And at one point, I swear they like started to come towards each other, and then they went like that, and they went in the opposite direction. It was just so cool. You could see it reflected in the water. And it goes back to my point earlier that they come in lots of different shapes and sizes and vibrancies, or different levels of vibrancy. And they can also be really unpredictable. Sometimes you're out there all night and you wait for like an hour or two and nothing happens. And then 10 minutes later, it comes to life and then it disappears almost instantly. So it is a really challenging thing to view. but I think that's also what makes it kind of beautiful. It's not guaranteed every time. You have to kind of go out there under the right conditions and just cross your fingers, the best you can do. All right. I believe that is time for Q&A. I really love those questions. I really love the opportunity to do this. And I do want to redirect you to knowing that there are other presentations going on throughout Boreal Stargazing Week. We've got Dark Sky Magic with Dacia and expeditions and education. We've got a NASA scientist coming to speak on Thursday. And we've also got live programs. So if you're located anywhere in Minnesota, check our website to see what is the closest one to you, because we've got so many cool things lined up. Last thing I'll say is if you have any questions that I wasn't able to get to, please shoot me an email. You can shoot at the email that we've already been we've been discussing with one another. That's education@voyageurs.org. I would love to answer any other questions that you have. All right, and with that, really appreciate you coming, and we will see you for the next presentation. Thank you all so much.